That's me. Hey guys, probability of overlapping events. Probability of overlapping events. For two overlapping events, the probability that either of the events occurs is the sum of the probability of the events, just like with this joint, but minus the probability of their common outcome. Okay? For instance, earlier we had the roll of 2 or roll of prime. Think about this. What's the probability that I roll a 2? 1 out of 6. Oh, thank you. 1 out of 6. What's the probability that I roll a prime? Well, 0 is not a prime. 1 is not a prime. 2 is a prime. 3 is a prime. 4 is not a prime. 5 is a prime. 6 is not a prime. So it's 3 out of 6. So the probability would be 1 out of 6 plus 3 out of 6. So that's 4 out of 6. But I have to subtract. What's their common outcome? What is their common outcome? The 2 is their common outcome. So I have to subtract the probability of getting a 2, which is 1 out of 6, and that brings me back down to 3 out of 6, which is 1/2. Okay? So we add their probabilities together, and then we subtract the probability of getting a common outcome for both of them. Let's look at this one and see if I get it right. You guys help me on this. Okay, this says you roll 2 number cubes, a red and a blue one. Okay, good. What is the probability that you roll a 4 on at least one of the number cubes? Well, what's the probability that I'm going to roll a 4 on the first number cube? Miles? 1 out of 6. Okay. And what's the probability that I'm going to roll a 4 on the second cube? Nicholas?
1 out of 6.
1 out of 6. Okay? So my probability of getting, I need to add those together, and that's going to give me 2 out of 6. But wait a minute. Wait a minute. What's the probability that I roll a 4 on both when they get a common outcome? What is the probability of that happening? Kentaro?
Is that 1 out of 12?
No, it's not 1 out of 12. It's close. Remember, when I want to find the probability of both things happening, I multiply them. What do you think the probability would be, Milan?
2.
Not 2 out of 12. Hey guys, I could roll a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. I could roll a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4, a 2 and a 5. A 2. How many different combinations are there, Kentaro?
36.
There are 36 combinations. How many of them do we have a 4 for both of them? And it's asking us how many of these combinations is a common or an overlapping event. How many of them, Dane?
1 out of 36.
1 out of 36. So I need to do 2 out of 6 minus 1 out of 36. Now we don't have common denominators here, do we? No. So I need to get a common denominator. The common denominator is what? Spencer? Between 6 and 36.
It's 36.
It's 36. I don't need to change the last one. But what did I do to the first one to make the denominator 36? Henry?
Multiply it by 6 by 2.
No, I multiplied 6 by, Berta? 6. So I need to multiply 2 by 6.
Oh.
And I get 12. So 12 over 36 minus 1 over 36 gives me 11 over 36. That is the probability that I roll a 4 on just one of them. All right? Thank you, guys. Let's look at the next one.